Good day, students. Today we are considering a topic which is harmonics and overtone in a stressed string. We want to see how it takes place in a stressed string. Example, when you plug a string, e.g., guitar, the first loop that you have before you have subsequent loops is called the fundamental frequency and is the strongest audible frequency. Other loops are not as loud as the first loop. Use the first loop, for example. You have the other ones coming, but use the first loop, and that's the F naught. You have the 2 F naught, 3 F naught. The first one is called the first harmonics. The second one here is called second harmonics. The third one is called the third harmonics. The first harmonics is called the fundamental frequency. Second harmonics or first overtone. The first overtone starts from the second harmonics. The third harmonics or second overtone. You'll be reducing it by 1. Second to first overtone. These are quieter or softer frequency, but the fundamental frequency gives us the strongest audible frequency. As I said, fundamental frequency is the lowest frequency but the strongest audible frequency. The overtones are higher frequency that are quieter or softer than the fundamental notes. Overtones are the next frequency or mode of vibrations that a body can emit that are above the fundamental frequency. Overtones are integral multiples or whole number multiples of the fundamental frequency. Overtones again are the whole number multiples of the fundamental frequency, which are called harmonics. It must be whole number multiples before it's being called the harmonics. That's why we call this one harmonics, because they are whole number multiples of the fundamental frequency. You can see 2F note, 3F note, whole number multiples of the fundamental frequency before it can be called harmonics. And also is the overtone. I said it again. Overtones is the whole number multiples of the fundamental frequency, which is called the harmonics. And the first fundamental frequency, that is the first harmonics, the fundamental frequency is called the first harmonics, where you have the first loop. That's where you have the fundamental frequency, which is also called the first harmonics. Overtones may or may not be harmonics. For example, in a bell. When you ring a bell, it's not the frequency produced in a bell, ringing of a bell, is not the integral multiple of the fundamental frequency. Since it's like that, it's not an harmonics. Overtone in a bell is not the integral multiple, the frequency produced in a bell it's not the integral multiples of the fundamental frequency. Because of that, it's not an harmonics. Please, let's take note. Let's analyze our diagram. I told you that the first loop that you have, when you have from here to here, which is L, is lambda over 2, give us L to be lambda over 2 plus multiply lambda equals to 2L. Go back to your formula, V equals to F naught lambda, divide by lambda, divide by lambda, lambda cancel lambda, F naught equals V over lambda, which is V over 2L. This is your fundamental frequency. Therefore, fundamental frequency V over 2L. Please take note of this, let it be in your memory. Fundamental frequency equals to V over 2L. Now, when you now come to the first overtone, I said we have two loops, which is you now have L to be lambda over 2 plus lambda over 2, which is LCM is 2, lambda plus lambda, which is 2 lambda over 2, 2 cancel 2. L equals to lambda. That means that half, when you bring two halves together, will give you lambda. Now let's get our second harmonics, which is V equals to F1 lambda. F1 now equal to V over lambda equal to V over L. Notice that when you bring these two together, equals to V over 2L plus V over 2L. From here, let's see, V over 2L plus V over 2L will give us 2L V plus V equals to SCN 1 times V, that's V, plus V, that's 2V over 2L. 2 cancel 2, that's V over L. That means that when you bring 2 together, 2V over 2L together, you give us V over L. That means that you now have F1 to be F naught plus F naught equals to 2F naught. For the first overtone takes give us 2F naught. That's the first overtone give us 2F naught. That's how to get that. For the second overtone, we have 3 loops. You now have L to be lambda over 2 plus lambda over 2 plus lambda over 2. LCM is 2. Lambda plus lambda plus lambda. 2 goes to 2, 1 times 1 lambda, which is 3 lambda over 2. Now L equals to 3 lambda over 2 plus multiply. You want to make lambda the subject of the formula, you must make lambda the subject of the formula. Now you now have 3 lambda equals to 2L divided by 3. Divided by 3. 3 cancel 3. Lambda equals to 2L over 3. Now let's go back to, we make this one F1. The first one is F naught. F1, second one is F2. V equals to F2 lambda. Now F2 equals to V over lambda. We need to substitute for this lambda. That's why we make lambda the subject of the formula from here, which is V over 2L over 3. Take note, this moves close together, equal to V over 1 divided by 2L over 3 plus V over 1 times 3 over 2L. Change it to times, which is 3 V over 2L. This one is F naught. I see F naught equals to 3 F naught. You can see that you have, what you have now is F naught. The harmonic, first harmonic is F naught, 2 F naught, 3 F naught. This is our first overtone, second overtone, with first harmonics, second harmonics, third harmonics. You can be given the fundamental frequency and be asked to look for the first overtone. You will say 2 times the value given to you for the fundamental frequency. This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.